Hello everyone, and welcome to another update concerning what's new with the Ziti browser stack. In the previous video, you saw how our new IDP integration leveraged Ziti's new external JWT signer authentication as a technique for bootstrapping trust of the web app user onto the Ziti network, and then ultimately gaining access to the web app that is inaccessible to the open internet. Today, in this video, I'll briefly describe some enhancements to the Ziti browser runtime that leverage some new WebAssembly-based TLS, and we'll be retiring the old TLS handshake and encrypt-decrypt that we were doing in pure JavaScript. The WebAssembly that I'm referring to originates in the OpenSSL C language library, and we have cross-compiled that over into WebAssembly and then wrapped it in a sufficient way to make it accessible to the JavaScript-based Ziti browser runtime. One of the things that occurred during this phase of the project was the WebAssembly bundle itself grew. You may recall from previous demos that we were doing some PKI work already using the WebAssembly, the key pair generation, CSRs, and insert acquisition interactions with the Ziti controller. Introducing the new TLS logic, all of the machinery there for the encrypt-decrypt, made the bundle of just the WebAssembly grow to somewhere between 3 and 4 megabytes. When you start piling that inside the Ziti core and then the core inside the runtime, the eventual single file bundle, it grew almost 10 megabytes. And the problem was the browser, in this case Chrome, just wouldn't load the service worker anymore. It was too big. So I had to take a step back and refactor things to load the WebAssembly bundle itself separately from the rest of the Ziti browser runtime. So let me show you what I'm talking about. Let's get into a network tab and watch all the traffic and then load the app. Again, running the Ziti HTTP agent locally, and behind that I have a dark Mattermost instance. So that's the same app we've been using for all the demos. The Ziti browser runtime in previous demos was being loaded from a CDN. It is now being loaded from the Ziti service worker. And the reason for that is the machinery that loads the WebAssembly, the linkage between the Ziti browser runtime's JavaScript and the instantiation of the WebAssembly within the browser, is such that the separate load, and here it is. I'll just preview this. The browser knows how to decompile, so there's at least a fragment of WebAssembly in all of its glory. Hover over this, 3.8 megabytes. So when the runtime is instantiating itself and going through its initialization sequence, it will do a separate load of this, and it has to be done to the server that it was loaded from. A separate Ziti kitchen or a separate deep dive into the machinery of some of the new underpinnings of the Ziti HTTP agent, how it finds the runtime, how it finds the WebAssembly bundle, how it finds a service worker, is something that I will tee up for a separate video. But I just wanted to point out that things are now working properly, both in the runtime as well as the service worker side of the Ziti browser stack, by virtue of us separating out this WebAssembly. So the previous generation of the Ziti browser stack was doing JavaScript based. All of the TLS work was being done in pure JavaScript, and we could only get up to the TLS 1.2 level. We're going to be retiring that now that we have WebAssembly-based TLS. So this will go away once I start shipping all of this code. I'll rip this out, and we'll use basically just this. But those are the cipher suites that the WebSocket-enabled edge router knows about and wants to play with. And those are the same cipher suites that I have built into the WebAssembly on the Ziti browser runtime side. If we look at the messages that are going back and forth over the WebSocket and click open any of them, you can see here at the front, the header, this 170303. They're all going to be like that. So just for grins, I bring open this website, TLS 13 illustrated, and they talk about how the various records, here we go. They talk about how the various records have a 1703 in the front, and how the protocol is basically hiding itself within 1.2 as data. So at any rate, just wanted to show you that we are indeed running across the wire at the TLS 1.3 level. Another thing that's worth pointing out, the Ziti service worker is now maintaining its own cache of certain resources like JavaScript files, some images, some CSS fonts, those types of things in this new cache that I call Ziti browser cache. And there are some rather large things that we needn't go back across the wire to fetch. And the point of that is, if I was to close this tab, bring open a new tab, and imagine some time has gone by and we go back into the app, it loads fairly quickly. So let's do that again. Let's close the tab. Let's open up a new one. Click 1001, 1002, 1003. Okay, it's about 3 seconds. I do the app native outside of Ziti. 1001, 1002, 2 seconds, about the same. And this is not an incognito tab. This is just normal browsing. So everything will be persistent. Again, close this, imagine walking away, new tab, bring up the app, wait 1 or 2 seconds, and you're back in. So that's the use case that we're looking for. All of the details surrounding how the JavaScript within the Ziti browser runtime interacts with the new TLS WebAssembly code, how it streams things at the socket level abstraction, how it does all the asynchronous I/O, how it crosses the boundary. Those are details that are too long and intricate to bake into this video, but I'll break that out, do a Ziti Kitchen style walkthrough. And maybe some blog posts. So watch for that kind of separate from this, but I just wanted to let you know that the new TLS encrypt, decrypt, handshake, TLS 1.3 WebAssembly code is alive and kicking, and some of the performance problems that we've seen in the past have been alleviated. If you watch this and you have any comments, any questions, love to hear from you over again on our Discord site. So please let us know if you're interested in finding out more. And until next time, I appreciate you watching, and I'll be back soon with another Ziti browser demo. Stay tuned.